Hello and welcome to another tutorial. So this time around we are going to be continuing our Sim style AI series, and what we're going to be doing is we are going to be giving the Sims some basic memories, in particular memories of interactions that have gone particularly poorly or particularly badly, and have those memories be able to have an effect on the stats for the AI and also have the concept of memories that can be both short-term and those being able to be reinforced and becoming long-term memories. So let's dive on in and get started. Now, actually, the first thing that we're going to do is we're going to actually do a couple of improvements to the blackboard. And shout out to R1P Fake for the mention of this. They suggested in the video for the blackboard a way of being able to improve it. So I'm going to get that set up now. Generics in C# are one of those things I often forget about ways of doing things neater and cleaner with it because I don't actually use generics that often. I tend to use generics, the templates in C++ a lot, but often forget about the ones in C#. So with our gets here, we do have a lot of repeated code of what we're doing. So what I can actually do is I can set up a generic version of this, which I'll put it down here. So what we'll have is we will have, and I'm going to make this private because other things don't need to be able to access it. So we'll have a get, and we're making this a generic function. So what this is going to do is we give it the dictionary that it's trying to retrieve stuff from. We give it the blackboard key. And I'm just going to change the name of this to key set. Then what this is going to do is, well, if the key set does not contain that particular key, then what I can do is I can throw an exception. So we can throw argument exception, and we can give a little bit more information here. So could not find value for key, and we can then indicate which particular one we couldn't find it in. So we can get type of that, and we can get the name, and because of how the things are actually named, that will correctly correspond to the particular one we were trying to retrieve from. Otherwise, we can return key set key, like that. So that gives us a generic get function. I'm also going to set up a try get version of that. So the try get is going to be fairly similar, except it returns a bool indicating whether or not it's actually successful. So if it can't find it, it will return false. If it does contain it, it's going to return true. And because it's a try get, it actually passes back the particular value. So we have out t value, and we provide a default value. That is value is key set key, like that. So that looks good for these new functions. So what I'm going to do is I'm going to bring them down nearer to where we've got our generic set of ones. So these will work for any of our ones with our integers, floats, similar things like that. So what these become is this ends up being a return, a get, values, key, like that. Try get ends up becoming a return try get in values. So it removes quite a bit of code for our particular ones. especially for these generic ones that we've set up. It eliminates quite a lot. So float values E. So anything that reduces the amount of code that we've got, always good. Especially in scenarios like this where it removes it and runs things then through a generic code path. Just makes for a much better setup. The IntelliSense being very, very on point simplifies the process of getting it updated quite a bit. You can see, although we added in some extra code, most of what we're doing is removing code and helps us also in the process fix bugs like of this, where we had string values one referring to incorrect setup there. Good. Do a similar thing with this one. So get any of our ones that are using this approach are able to actually use this new setup. So try get. See there. So that's the thing, it's a lot easier to spot potential errors with this as well, which is really important. Anything that makes it easier to eliminate problems or spot problems is always good. Pretty good, and we've eliminated quite a large amount of code in the process of this. So that's good. We've got our blackboard cleaned up a bit. So it does thin down the amount of code quite significantly, which is good. So much less code, always better. And we won't see any issues, but always good to just head back to Unity just to check there's no particular problems happening, which there's not. So that's good. So now we can start to look at setting up the memories. So what we want to have happen is if I run this, the moment our little AIs can go and use particular things, and whether they, the interaction there, is always successful, the result is always the same. What we want to do is be able to have that interaction be sometimes very successful, sometimes very unsuccessful, and that those sort of critical successes, critical failures actually have an impact, that they can form a memory that impacts on the AI going forward. So it's the interaction side of things that we're going to start with to begin. So we want to make it that those interactions have the ability to be successful or unsuccessful, things like that. So I'm going to head over to the base interaction here, and we're going to be starting to make a few changes. So one of the things is this idea of a critical success, critical failure. We've got interactions that are instantaneous. Makes sense for those. We've got ones that run over time that actually apply small stat changes progressively. For those, it doesn't quite fit as nicely just having a critical success or failure unless we interrupt it. We also could have ones where the effect happens, they interact with it for a time, and then the actual effect happens. So I'm going to add in support for those as well. So I'm going to have this after time. So an interaction that after a period of time, it actually applies its effect. Okay, so we've set up so we'll be able to add that in, which we'll do in a little bit. What I need to be able to do is set up support for the different types of outcomes that can happen from an interaction. This is again going to be a system serializable public class. And this is our interaction outcome. And a couple of things that we're going to need to be able to be doing with this. So one thing, I'm going to give it a description. So we can say, hey, X happened. So it's going to have a description. It's going to have a weighting. So I'm not going to call it duration. It's a decent guess for its setup, but we're going to call it a weighting, which will default that to 1. It's going to have a multiplier for whatever stats it affects. So this will be our stat multiplier, which I'm going to again default to 1, so it has no effect. I need an array of interaction stat changes to indicate what stats it's actually making a modification to. And eventually there will be a setup here for the actual memory that it causes, which I'm not going to keep that for now. And then we're going to have a system non-serialized float normalized weighting. Actually, rather than doing it non-serialized like that, I'm just going to make this a property. I'm going to default it to 0 so that I know I have to actually normalize it. I'll set it to -1. We'll make it really obvious that it's got issues there if it hasn't been set up properly. So now I can have my interaction outcomes. So this is my set of potential outcomes that can actually happen. So outcomes. And what I'm going to do is that is a new interaction outcome. And I'm going to actually have 1 initially by default. Initial interaction outcome, which I want to give it a couple of values to start. So it's weighting, it's going to be 1. Its description, it's going to be empty. So just a blank one essentially. So that I've just got that there as a starting point. So that's good. I want to be able to keep track of have I normalized these modifiers. So this is where, because it's it's a non-behavior, so I can trust that private will mean it's non-serialized. Sometimes with scriptable objects, you can't always trust that a thing that is private won't be serialized. So what I can do is keep track here of outcome weightings, normalized. Just so I know if they've been actually normalized or not. So this, I should be able to set up some outcomes for things like of our microwave and stuff like of that. So the microwave, so our outcomes here. So what I can do is I'm going to chuck in two sort of ones that actually will have a major effect. So we're going to have amazing food. And I'm going to make it that is a 40% chance of happening. And that will boost stats by 1.2, which in this case, the actual stat that it's going to change, going to make it that it will boost energy, and let's also boost fun. It's good, that's how it's going to boost those. We can actually just say 1 for that, and then the stat modifier will be multiplied again by that. So that looks good. We'll just make those so it's boosting them both. And then we're going to have terrible food. So that is also going to be a 40% chance of happening. And that is going to reduce stats. And again, we'll add in affecting the same two stats of energy and fun. And it's going to, again, make sure it's reducing those. And then the default is just going to be average food. It's not going to affect any stats. Its weighting will be 0.2. So it's good. We've got our setup for with the microwave of what will actually happen. So now we want to start applying some of these effects, being able to have it actually sort of apply potentially the modifiers. So what I'm going to do is apply the stat changes. I'm going to actually rename this to apply interaction effects. And I'm going to give this a bool and a roll for outcomes, just so that we can control whether or not it actually should apply the outcomes. And I might make it that the outcome also has the option for abandoning the interaction. And Boolean indicating if it should abandon the interaction or not. Just have a return true indicating that it continues. So, okay, first thing I need to do is check if we're actually applying these outcomes. So if we're supposed to be rolling for these outcomes or not, then what I'm going to do is first check if they need to be normalized. So if we've not normalized them, then we're going to do that. The other thing we're going to check here is, do we actually have outcomes? If we don't have any outcomes, then there's nothing for us to actually be doing here. So outcomes, if that length is 0, oh sorry, we only run it if it's greater than 0. So if we need to normalize them, so first thing we need to do is we need to weighting sum is 0, loop through all of them, and then that weighting sum, we add that, and then we go through the outcomes again. The difference being that this time we go outcome normalized weighting is equal to the outcome weighting divided by the weighting sum. So we'll also set this to true here. So normalize the weightings if needed. Fit up here, cool. And then interaction, just so that we can then have that be being set as part of the process here. So, okay, we've normalized the outcomes. Now we need to actually pick an outcome. So, pick an outcome. So what I'm going to do is I'm going to do a random roll first. Oh, float. Random roll. I'll just do a random and value. That'll be between 0 and 1. So then what we do is for each outcomes, if the outcomes normalized weighting is less than or equal to the random roll, then that outcome is going to be the one that gets selected. So I'm going to set up here, interaction outcome, selected outcome, which I'll default to null. Here I would do selected outcome, that's that. And we break. Otherwise, our random roll, we subtract our outcomes normalized weighting. So, okay, we've gone and done the process for actually picking the outcome. Now, what I can do is start to extract things from it. So our stat multiplier, well, if we have a selected outcome, then we use that stat multiplier, otherwise it's 1. So that means when we're applying the changes down here, we'll do stat multiplier by that. We can also check here if the selected outcome, and if it indicates that we're abandoning interaction, then abandon interaction gets forced to true. So that's good so far. Now, this is going to be applying those particular stats, but we also have stat changes that should get applied from the particular one that's been selected. So what I can do is if selected outcome, then for each, notice if the selected outcome is not equal to null. So selected outcome in, and then so this is our stat change in selected outcome and our stat changes. And these just get applied in the exact same way, except we don't apply the multiplier. So that multiplier is for whatever the stat changes would have been, whereas this is just going to use the actual particular changes. So that's good. We've applied those stat changes. Now we want to go and update areas where this was being used. So we can search in the project, or we can find references. So if I find all the references, we've only got a couple of cases where we're using it. So one is instantaneous. So with instantaneous, it doesn't matter whether we can roll for outcomes there, whether it's abandons the interaction or not, doesn't actually matter for that. And then we also have one here. Now this, it does matter. So here, what I need to do is have a bool abandon interaction. It's false. Now if we check what this returns, so it's returning if it should abandon the interaction, it actually returns false. So true means everything's fine for it to continue running, whereas false means that it should actually abandon that. So what we can do is I'll actually rename that to continue interaction. Do it like that. We can say true in terms of, so rolling for it, we wouldn't want to actually do it at this point. We'd only want to roll if we're actually at the final change. So we'll get to that in a second. So here we would say if it is not continuing interaction, or that. So this, we need to kind of know if this is the very last time that it's going to be running. So this I'm going to bring up here. So it is final tick, like that. So I'll only apply those interaction effects on that final tick. That just makes it so that we don't go and continually apply it. So it's not a case of every single tick, it's now a fabulous meal or it's now a terrible meal. We only really want to run it that one particular time. So that's good. We can also, while we're here, get things set up for that new type of interaction. We added the one for where it applies after a particular time. So in this case, if the stat changes, that, and we can check our interaction type. So if the interaction type is equal to over time, then we apply the interaction effects. So, okay, if it's over time, we always apply it. The other scenario where we'd apply it is for interaction type is our after time, and this is the final tick. So either of these two ones, I'm just going to make sure we've got these grouped. So if our stat changes, we actually have ones, and we're either working overtime or it's after a time and this is the final tick, then we apply the interaction effects. So that looks good. So, okay, we should see a case where our ones roll for an outcome and those actually can apply. What I will do is when it's selected an outcome was, and what we'll do is we'll go selected outcome description. Okay, so we can test this out, and what we're looking for is one of them using the microwave, which after one of them gets hungry enough, they'll inevitably go and use that because they need to actually eat. So there we go, someone's going to use the microwave. So we'll see what we get outcome-wise. So they're using it for a bit, they got amazing food, which is good. So, okay, now we need these interactions to be able to form memories. So I'm going to set up so we have memories here. I'll try naming that correctly. And naming the script for this is a challenging one because memory is actually a really commonly used term. And so I'm going to call it a memory fragment. So the idea is that a memory fragment is something that can become a permanent thing. So I'm going to actually make this a scriptable object. We will have to actually create these memory fragment assets, and then they'll have data on them that's keeping track of sort of the type of memory, the intensity of it, things like that. So we're going to have our create asset menu, menu name, and that's going to be AI memory. Your file name going to just be memory. And get rid of our start and update. So memories are going to have a name associated with them. So they're going to have a name. They're going to have a description. So going to have a default duration that they last for. And we set that as 0 by default. They're going to have stat changes that they cause as a permanent thing. So our interaction stat change. And one memory could cancel another. So I want to actually keep track of a memory fragment, which ones that it's able to cancel. So memories counted. And then the thing that I'm not going to serialize, so system non-serialized, and this is going to be the number of occurrences. Actually, I'll just mark this as a property. Times that it's occurred, and mark that like that. So that's good. So for the particular outcomes, we need to have here the memories that it's able to cause. Caused. And then down here, our selected outcome, we've got memories caused. Then we're going to need to be able to apply those particular memories. So those will actually be something that we add to the performer. So I'm going to have performer add memory. And what I want to do is I'll have actually just an add memories. So selected outcome memories caused. So that's good. So that's going to be something that the performer has. So we can go to our common AI base. It's going to have a public void add memories, a fragment, memories to add. So that's good. We've got our base interaction able to be doing that. So we've got pretty much the key things that we need to be having happening there, which is excellent. We just want to double check and make sure that we've got everything updated in terms of stat changes. So we can see here with perform, we do actually need to be updating this so that it works for if our interaction type is the after time. So over time, after time, follow a similar process there. So we just want to make sure that that's properly set up. Now we can start to do things with these memories because we've got a logic for being able to add them. Now we need to have those memories do something, have them actually have an effect. So if we head over to our AI, it's going to need to keep track of these memories. And the blackboard makes the most sense as the location to actually keep track of them in. So what we're going to do is add in some new keys to our blackboard. So what I'm going to add in is I'm going to add in a key for recent memories. I have memories, I might actually call it short term, and memories long term. So these will be complex things that are stored in our blackboard. Now we want to also have the ability for an AI to control how long it takes for a memory to become permanent. So we're going to have serialize field int permanence. Well, we'll say long-term memory threshold. So how many times a particular memory needs to occur before it then gets transferred over to long-term memory. And that's occur sort of, essentially overlapping. So long-term memory threshold, and I'm going to set that fairly low, just so it very easily happens. So, okay, we need to be able to add a memory. So when we go to add a memory, what I'm going to do is memory in our memories to add, and just do an add memory of that, because a lot of the stuff is going to be very common. So then we're going to have a protected void add memory as our memory fragment. So, okay, what we want to do is, firstly, we want to check, is this already in our permanent memory? So I need to retrieve that permanent memory as the starting point. So the permanent memory is going to be a list of memory fragments, permanent memories. So we want to get our individual blackboard, get generic, and what this is going to be retrieving is we go for our blackboard key, long-term memories. So get generic, we need to give it the particular type. This is a list of memory fragments, like that. Now, because this is a very complex thing that's being stored here, I need to make sure I push that into blackboard at the very beginning. So individual blackboard, set generic, and we can give it the blackboard key of long term. And what we're setting is a new list of memory fragments, like that. And we need to do that for both the short and the long term. So because it's a complex type, because it's being stored in a very generic way, we need to work with it like that. So that's our permanent memories. We know further down, almost certainly, we're going to have our short-term memories, or our recent memories. So retrieve that. That's good so far. So what I want to do is this already in our permanent memory? Because if it is, we don't need to do anything. In permanent memory already. So for each memory in our permanent ones, for this memory to add, to make it clearer. So what I want to do is I want to check if this memory is the same as that. Now, I could override the equals operator, but what I'm going to be doing is, because these are scriptable objects that I'm instantiating, it gets a little tricky for doing that equals. I need to be operating on just very specific data. So what I'm actually going to do is I'm going to add in here if memory is similar to, and we'll check if the memory to add is similar to, which I don't have that function yet. So if it's similar to it, then I'm just going to return. There's nothing we need to do. So I'm going to set up all of these functions that don't actually do anything yet, and that I haven't implemented. This is an approach I like to use of writing how I'm going to use the code, have that generate compile errors, and then work by fixing those compile errors. I find that sort of a good approach. The other thing that could happen is, does this cancel a long-term memory? So what I need to do is check that for if it actually does cancel it. Now I could do that actually as part of this. So what I could have is, I'll store here memory fragment, memory to cancel. What's that? So I want to check if that memory to add, if it would cancel the particular one. So I can do this as if memory is cancelled by memory to add. If it is, then memory to cancel is that. The one actually that we're looping over. So if memory to cancel is not equal to null, so then I need to remove that from the permanent memories. So permanent memories, remove memory to cancel, like that. So I've removed that, so it's no longer able to be applying. I need to go and make sure I update our long-term memories. So we'll do set generic. We make sure we set the long-term ones and our permanent memories, because we've gone and modified those. So that's good. So we've handled cancelling a permanent memory. We've handled if it's already there, so we don't need to do anything. It also could be the case that it could cancel a short-term memory. So we're going to need to check down here, does this cancel a recent memory. So for each memory in our recent ones, we do the exact same check that we did here of checking if it is cancelled by. If it is cancelled by it, then again, do the same process. So just reusing existing stuff. So in this case, we update the recent memories. So make sure those get updated. Memory short term. And in this case, we're just going to return if we've gone and cancelled that particular memory, then we just remove it. So I'm actually not going to return here, because what I want to do is, even if it's cancelled a recent memory, this current one, I still want to actually apply it as a new memory. So this is good. What I want to do is also check if we have an existing memory for that, because that might mean we're reinforcing it or something like that. So existing recent memory. To do a similar check to what we were doing up here, so if memory to add is similar to memory, then the existing memory, we just keep track of that. So okay, we've handled if it's a permanent memory, being able to do nothing if it's the same. We've handled being able to cancel it and apply that. We've handled if it's a recent memory, doing that cancelling and checking if we already have an existing one for it. So if there's no existing recent memory, so if that is null, then it's quite straightforward. Recent memories, add. Now I want to create a copy of this. So again, I'm going to say memory to add, duplicate, which is a function that doesn't exist yet, and that's okay. And then I update the memories. So otherwise, it's a little bit more complicated. So otherwise, what I need to do is I need to check for reinforcing this memory potentially. So what I'm going to do is the existing memory, I'm going to go reinforce. So it increases the occurrence of that. It's also going to potentially modify things like the duration, but I'm going to reinforce that memory because now I want to check, has that memory become permanent? So if that existing recent memory occurrences is greater than the long-term memory threshold, then what I need to do is I need to transfer that memory. So what I would say is our permanent memories, we add our existing recent memory to that. Our recent memories, we remove it. And then we go and we make sure we update both of our sets of data. So both our short and long-term memories, we update those in our blackboard. So this is good. So we can actually, at this point, I'm going to say debug log memory. And we'll put in the description here. So existing recent memory. Name permanent. Actually, we might use the name. So that's good. So now we have our functions that we need to add. We've got our is similar to, our is cancelled by, and our duplicate and reinforce functions that we need to get set up. So these are the ones that are going to do a lot of the work there. So, okay, let's set these up. So in our memory fragment, I have a public bool is similar to, And we have that. Now this is going to be pretty straightforward. What I'm going to do is I'm going to just compare the names and the descriptions. So if name is equal to other name and description is equal to other description, like that. So that's good for the is similar to. Let's have our is cancelled by. And we have the other like that. So what I would need to do in this case is for each. So what I'd have is for our fragment in memories counted. So F fragment is similar to other. Then yes, it does cancel it. Otherwise, we return false. That's good. We've got our is similar to and our is cancelled by. Going to have our reinforce. So void reinforce other memory fragment. So occurrences, it's increased. Duration, and this is actually going to be the duration remaining. So what we would do is I'm going to actually have this be a separate thing here. Public int or public float duration remaining. Like that. Can default to 0. So the duration remaining is going to be the maximum two ones. Good. So it's our reinforce. Okay, so we can now set up our duplicate function. So we're going to have, this will return a memory fragment. It's just called duplicate. And all it needs to do is return. We can just go scriptable object, instantiate, and we give it ourselves. It'll create a copy of that. What it could do is make sure that it properly resets things when that happens. So new fragment, new memory. Make sure occurrences get set to 1 and duration remaining gets set to 0. Well, actually, get set to the duration. Now we need to make sure these are both being done on the new memory, like that. So that's good. So we've got our duplicate function set up. So that means all of our errors here are gone. Everything is happy then in terms of that setup. So we're pretty close to actually having this done. We do want to go back and make sure that everything is happy here, because there could easily be some errors. So that, some stray code there, it's all good. So just make sure we've got no errors, then we'll be able to actually set up our memory data. So that's good, we've got no errors. We can set up our individual things now. So I'm going to set up a folder for data. And we can set up a folder for the scripts. So we'll just put the memory fragment one into that, which will make this get a little bit grumpy, but that's fine. So for the data, well, we're going to create a memory for bad food, and we'll do a similar thing for good food. Bad food. ate terrible food. And what we'll do is we'll say the duration 60 that it lasts for, and stat change wise, I just have it actually only affect the, we'll say the fun stat. And in terms of the effect there, we'll say that it decreases it. So I'm going to duplicate that. And this is going to be good food. The first thing I want to do is mark that bad food count as good food. And then good food count as bad food. So largely these are just going to be mirrors of each other. Now I can link these up so that outcome-wise, well, if we have amazing food, that's going to cause the good food outcome or good food memory. Otherwise, we cause the bad food memory. So that's good. We've got those linked up. So those memories will happen. They'll get caused. Now, they're not causing any effect yet. So they exist. They're not actually going to be impacting on anything like of the stats or that yet. So that is something where we do want to have them be able to impact on stats. We also need to remember these memories have to actually have an effect over time, and that they have a duration, and that duration can actually reduce. So what I'm going to do is I'm going to just grab my code here. I'm grabbing these particular memories, and in our common AI base, we're going to do some ticking of these. So we're going to retrieve these recent memories, and we're going to retrieve the permanent ones as well, in case there's anything we need to do with that. So I can loop over those recent memories. So recent memory, we'll just call this memory in recent memories. And then I want to be able to adjust the duration of that. So that becomes a for each. So memory duration remaining is equal to, so we'll update that with the time.delta time. Now that, we can't just tick it like that. So we need to actually have memory tick. And we will actually provide it the delta time in case we wanted to be able to be scaling that. So, okay. If we go to our memory fragment, I need a tick function. Public bool tick delta time. Duration remaining. We subtract that, and then we return. So if the duration remaining is greater than 0, it'll be true, indicating that it needs to keep ticking. So if this is false, we want to be able to remove this memory. So this is where it's actually going to be easier for me to change this to for index is less than recent memories count -1. That looks good. So recent memories index, and then what I would be doing here is I can go recent memories remove at index, and I just don't need to do anything else. I do want to keep track of the fact that those memories got changed, so I don't need the permanent ones. Now I don't want to do the set every single time. I only want to do the set if I've actually gone and changed stuff. So what I'm going to do is keep track here. Memories changed. It's false. Set that to true here. And if memories changed, Then I'll go and do a set on the blackboard. Just so that we're not doing that set all of the time, because otherwise that could easily get quite expensive. So tick recent memories. So that's good. So the memories now can be added. They can reinforce each other if they go from being a short-term one to a long-term one. Those memories can also be expired, which is good. Really, the only thing left now is the memories actually having an impact on the stat changes. So what I'm going to do is, for our not-so-simple AI, where we actually score the changes, I want the memories to impact on how it's going to actually score things. So our memories are going to need to be retrieved. So here, where we're retrieving our memories, we're going to follow this sort of approach. We're in our not-so-simple AI when we are scoring a change. I'm going to retrieve our recent memories. Now, scoring the change, we do a lot of ones there for that. So it might be helpful to, so we're not doing a lot of retrieving. I'm actually going to bring this up here of our recent memories. We will also have our permanent memories. So we'll retrieve memories long term. I'm going to pass both of these in. So recent memories and our permanent ones. So then what I can do here is list memory fragment, recent memories, and the same thing. It just saves me retrieving it all the time, because retrieving it from the blackboard isn't a cheap operation. So I do want to minimize the amount of times that it's actually going and doing that. So now I want the memory to be able to affect this score, so affect that current value. So I want to be able to do something like this, memory in recent memories. I want to check if this memory would apply to this particular stat. So if memory, and I need to loop over its stats, so for each stat, we'll call it change in memory stat changes. So if change linked stat matches, then what I would do is the current value gets multiplied by that. So I'm going to actually have a separate function here, modify based on memories. And what I will do is this going to bring in that linked AI stat, just because we do the exact same thing for the permanent memories, and I don't want to duplicate the code. So we'd have current value, and we would have a list of memory fragment. It would be memories. Just return current value, just so what I can do is bring that down here, and then I can go modify value based on memories. I'll give it the current value, give it the linked stat, we give it the recent memories, and I'll do the same thing with the permanent memories. So the idea being is that what now happens is the AI is going to modify how likely it is to do particular things based upon those memories. So the memories aren't just getting formed, those memories are actually now having an effect. So let us go and we'll just do a couple of things here where we've got stuff for being able to add the memories. So we can know when something becomes permanent. I want to also keep track of when something gets reinforced and when something gets added for the first time. So we're going to have a debug log, reinforced memory to add name. And then we will add here just an add memory. Added memory like that. So now we just want to keep track and look for those things where it's saying that it's adding and removing those memories. So we are ready to test this, but there is one fix that we need to make to where we're selecting the outcome. We do actually have this around the wrong way. Fix up that, and we'll also down here only output the debug log if the check string is null or empty. Selected outcome description, just so we're not outputting it when there's nothing actually to show. Because for things like average food and that, we don't actually show anything. So what I'm going to do is I'm going to make it that it's very high chance of amazing food and low chance of terrible food and no chance of average food. And I'm going to shut off the bookshelves. So what we should see is the object form a memory from the interaction. So we're already going to heat the microwave. So we should see it form a memory, and then if the same memory happens again, so it got good food, so it's heating food again, and depending upon, so it was bad food, so that will have cancelled out the good food memory. They're determined to be heating more food. They got good food. Now they're heating more food there, and good food, because they got it again, became permanent. So we have our setup working where we can be forming memories, where those memories can then become permanent if they happen multiple times, overlapping. So we've got that fact of being able to have the memories overlap and reinforce each other, which is good. So what will happen over time, because those affect the stats, is the AI's behavior is now shaped not just by whatever it's rolled as default, but also the things that happen to it. The sum total of its experience in the world is going to impact on how the AI behaves and interacts with the world, which is great. That starts to give more complex emergent behavior, which is really cool. So dive on in and experiment with it, see what things you might want to add, see additional memories, things like that you could be adding for different interactions. You could also have it that the AI starts with a bunch of initial memories, and you could randomize which set of ones, and that's again going to change how the AI views the world. Thanks folks, hope you found the video interesting and helpful. If you have, chuck in a like and subscribe, it really helps out, it's really appreciated. If you have any questions, chuck in a comment below. If you're looking for the code for the project, the code is available up on GitHub. There is a link to that in the description below as well. If you're trying to track down other videos, then I do have a searchable video archive, which is a link to that also below. And if you're looking for other ways to support the channel, then I do have a Patreon, and there's a link to that in the description also. But until next time, bye.